The game studios presents Fallout 5.
Okay. So I would say, do I have to like share the screen somewhere?
Oh.
Go to her.
Yeah, the
Yeah.
screen. All right. Yeah.
Oh yeah.
And
you. Get it.
Hey, bro.
She was looking at the weather. He was like, oh yeah.
Oh yeah.
Okay. Okay.
okay. With the presence of Code Blue, let's start our
Share the
presentation.
screen.
I think so.
Wait,
Um,
CJ, can you see it?
CJ, can you see the screen?
Yeah.
Okay, awesome. Okay, so hi everyone, I'm Ree. I'm going to present on how to do partition and why to do partition in SQL Server. So before we dive into partition, say if we do not have any partition, the basic way is to create a table and keep on inserting data one after another. The problem arises when the table becomes really big and we have to like do this following actions like select, insert, or delete. So whenever we're trying to do a select, we are going to block. We'll have to like log the whole table, and say if you want to like insert, you are locking the table so that other people cannot like go and do some query on it. And also, if you want to delete like a big chunk of data, say you want to delete a whole month of data, in that case, deleting takes a lot of time. And also in SQL, whenever you delete something, that information is stored in the transaction log. So say if you are deleting 1 million of data, you are actually keeping the whole transaction log for 1 million of data, which is going to make your transaction log really, really big. So one of the ways to overcome this is by doing different kinds of chunks. Say if we stored in one of the chunk only the data of 14th of the date, and in the middle chunk we store 15th date and the 16th in the next chunk. So say if you want to store data in another date, like the 17th of last month, we can just create another chunk and keep on storing there. The benefits of there is like if we want to do some kind of selection query, we can just look on those particular chunks and we can just do the queries. Also, if we want to insert, we can create another chunk and we just connect it with the other chunks. So as you can see, when it is inserting on the very last chunk, it is not locking out the chunks that are previous to that. So we can use concurrent, select, and insert, and also deletion. So yeah, so this is the basic concept of partition. Partition means it is going to like chunk different, it is going to divide the whole database into different chunks. And these different chunks are called partition. And there's another thing, in the SQL database, whenever we store something, we store it in the file group. So even if you don't create a partition, it actually has a partition. And the partition is 1 by default. So the whole thing is like a big chunk, and you're storing everything in that particular partition. So if you now want to create different partitions or like different chunks, you just create different partitions on addition to that. These different chunks that I'm saying, this is like an informal, non-technical term that I'm using. But in technical terms, these chunks are called file groups. And in these file groups, we are going to store different data. So a data on the last file group is not going to be of any date other than the designated one, and so on. So let's look into the types of file groups we have. Like I said, primary file is like the basic primary thing that every time you create a database, it is going to be assigned to that. And that is like the primary file, and it will have a particular size and everything. And that will be stored as a .mdf file type. You don't have to too much worry about it, but it's just I'm giving you the basic concept of how the files are stored in the database. So if you want to create a user-defined file group, it is going to be saved as a .mdf. And finally, the transaction logs are going to be stored as LDS. So if you have SQL Server installed in your local computers, you can go and try to look into your database, and you'll see there is always a .mdf file because that's the primary, and there's always a .ldf file, which is the transaction log. But for .mdf files to be there, you have to create additional file groups. Okay. So now let's go back to why and when to use partition. So I kind of talked about the information that when to use partition, but here's like some of the information in much more technical way. Like if you want to divide a large table into smaller chunks, oh, I did use the word chunk. Easily maintain a window of historical data. The window of historical data means, say, if you want to only store 7 days of data. So whenever a new day starts, you just discard the oldest day. So you always store 7 days of data. This is like the window. So it's like sliding window. Whenever a new day adds up, older day pops out. So this is how we can actually store historical data in a particular window span. We can divide the data in equal parts for certain criteria, improve data loading and reporting. The reason for data loading is, imagine we only want data for a particular date. We don't have to query in other places. We can just look into one particular partition and just load the data from there. So SQL actually gives us, I think so. So we can just look into that particular partition, and the query time will be really faster. Say if you have 365 partitions for each of the days of the year, then you can only look into one particular day instead of looking at other partitions. And say if we have like 1 million data in each of the days, you don't have to go and search 365 millions. Instead, you just query on 1 million, which makes it really faster. Now, I also talked about how it can actually solve the concurrency issue. So you can work on one partition and delete or insert other separate partitions. So it kind of solves the concurrency issue. Improve performance on maintenance operation, improve user experience. Okay, this is a little bit tricky. How does it really help user experience? Say if you are a user and you just, at the end of the day, you just, not the end of the day, the start of a new day, after the midnight, you want the data from the midnight thing. But if we don't use partition, for all of those data, we have to manually insert, not manually, I take that back. It's like systematically insert, but one at a time insert. So the user, say me, Kelly, and Elisa are actually querying. I might actually query a little bit earlier. I would say like 5 data. Kelly would say 10 data, Elisa would take 15 data, which is a little bit wrong, right? We want all the data to be on the same time. And this partition thing really gives us this benefit because it does not manually insert. I take that word back again, not manually. It doesn't add one by one, it adds by a chunk. And we will see how it does that. So as for a user, it's really fast, and it gives you a much more fluent user experience. And keep the size of the indexes too small. Now, I'm not going to talk too much about the indexes, but indexes are really closely aligned with partition. That's like a big area other than this. But just keep in mind, if you create indexes, they keep on getting bigger as the table gets bigger. But if you create indexes on different partitions, the indexes will start from each of the partitions. So if you say, for the first partition, there are like 1 million of data, the indexes are going to be from 0 to 1 million. But for the next partition, it will start from 0 again. But if we didn't have any partition, it will be just keeping adding up. So the partition size, the indexes size will keep on growing. But if we use partition, the indexes would be kept too small. Okay. Things to keep in mind before partitioning. There's a lot of technical things, so even though I have gotten it from the link, I'm going to post this PDF along with a document which has a lot of more information, and also a script that I'm going to show you in front of you. I'm not going to dive deep into these things, but if someone is really interested, they can go to that link and read more. The pros and cons, why not? Pros is like insert, delete a bunch of data. Historic data can be archived by sliding window technique. Now we know what the sliding window technique is. Can be automated by stored procedure and jobs. Cool. The cons are really important because it sounds really fascinating, but there are some downsides. One of them is it can negatively affect query performance. You might think that I just said that it performed better, but there are other cases. Say, you want data across different dates. Now it has to look across different partitions. It doesn't know which partition to look for. So what the SQL query execution plan is going to do, it is going to wait. It's going to hold on and keep on trying to identify which partition it would go through. Then it will go to those partitions and try to look for it. So instead of just going through like a table scan, like a straightforward scan, it is doing multiple steps before even doing the steps, which adds up. So at certain times, it can actually perform bad. Maintenance, this is really important because, you know, everything gets bad. Every job fails, and when it fails, it's going to be a nightmare. And say you are adding more data, but for some reason, the oldest partition did not get dropped. Now you have to do it manually, or you have to create more systems or more stored procedures, and that's like a big nightmare. But yeah, so maintenance is usually in big companies, they have designated DBA, and they kind of take care of all the partition themselves. And SQL Server does not automatically handle switching. So we will look into what switchings are, and they can be a little bit messy. So yeah, these are the terms that we need to know as we go to the script. Please ask me more questions if you find something that you don't understand. I can assure you I don't understand either, but we can mourn together. Yes. So, but now, hey, these are the terms. These are like the technical terms. And instead of giving you the technical definitions, I'm going to give you some, you know, non-technical definition about what these terms are. The file group, say the file group is the name of the place you want to keep your file. Don't even focus on the file group thing. Just think this is like the chunk, the name of the chunk. Okay? The file is like a physical file where the data is stored, where you want your data to be stored. Partition function, as it says, it's a function. As it has the name partition, it does some partition mumbo jumbo, and what it does is it stores data into different partitions. We'll look more into it, but for now, this is going to be our hero for the day. Partition scheme. So the scheme actually tells you the whole design of how the partitions are going to be. So there's going to be different partition, right? So we as humans kind of understand different things very easily, like the latest day is going to be at the front, and the oldest day is going to be way back. But the computer doesn't know that. In order to explain that to computer, you have to create a scheme, which will say, okay, I want this partition to be here, that partition to be there. That's what our scheme does. Partition range. Range is like, in a particular partition, what is the range of data that's going to be in that partition? I know a lot of words, but don't be afraid, because there are more to come. Trust me, you thought code was bad? Yeah, no. Okay, switch in and switch out. These are pretty similar. If you can conceptualize the previous things, switch in and switch out are really easy. Switch in is like inserting another chunk into the whole partition family. Switching out is just getting rid of the worst partition you always wanted to kick out, you know. So yeah, let's go and see these two types of partition. Okay, so we talked about a lot of ranges and stuff, right? So in partition, they are interchangeable with the word boundaries. And for the range, we just give them one boundary point. and it just assumes what is going to be the range based on that boundary point. So there are two ways of creating a partition function, and that is, one is like a left-based partition function, one is a right-based. Now, if you just look into the image below, you can see that there is some really long milliseconds to it. It's because it's a left-based partition. So it means the value that we provided, anything before it is going to be in one partition. Does it make sense? So the left means anything on the left side of it is part of it. But as you can see, it really looks bad, right? So we introduce you this, the right-based partition function, which means anything after that is inside that partition, which looks really good. But it really looks good for dead time. And we are going to use right-based partition for our case. But there can be other cases where a left-based partition function might be much more feasible. I'll keep that to your imagination. Oh, by the way, all of these are from different people. Their names are given there, and also the links are also provided. So if you guys really find them interesting, go there, check them out. Okay, so I talked about a lot of things that query performance can be negatively impacted. This is what I did for a few days here in NEURON data. I did some analysis and found that for certain cases, query performance can be bad. I don't want to bore you guys, so I'm just going to put a link and pretend that I know everything, and you guys can go and check it out. I can say the link still works, so yeah, that's okay. Otherwise, just believe me. And there are like query performance can be improved by, indexing. I'm not going to go too much into indexing for today. Oh yeah, now the fun begins. Let's implement partition. I mean, you guys don't have any computer, so I will implement it, and you guys can just cheer me as cheerleaders. Woo! Yes. So, okay. So now, whenever you run partition, make sure you run in a test environment. And that means if you want to run it, create your own database, okay? Don't use on other databases because it uses different file groups, which are like different addresses. You don't want to mess those things out, right? So in order to celebrate it, I'm not going to do it on my computer. I'm going to do it on a remote computer because why not? Seriously, I'm not going to do it on my computer. I have a lot of things to finish. So this script is really good. If you want to run it, it will just give you an error and say you cannot run it. The only way you can run it is by selecting different parts, because that's what we want, right? Okay, so there we go. I'm going to create a database. There is a lot of things there. I'm gonna make it bigger so that you guys can see. It just basically checks if that database exists. Otherwise, it creates it. So there's going to be a lot of things I'm going to do in this presentation, which you don't have to worry about. Just follow my voice, and just if you have any question, you can ask me. But there's a lot of things that we need to do that's not the focus of partition itself. So I'm creating this database. Right now, if I refresh this part, I will see there's a database called partition this. This is what we are going to use. That's why we say use partition, and you see there, this is where the partition this is been selected. Okay, now we are going to create different things. Okay, for our presentation, I'm going to use 1 million data for each of the partition because I want to show you guys that it's really helpful. Usually in the tutorials there's only the 1,000, but it doesn't really make sense because 1,000 of data is really fast to query, but I want 1 million of data. In order to do it, I'm going to create this way of doing it. You might think I am really good at SQL. I'm not, because this is created by someone else, okay? Okay. And yeah, but I'll pretend this is not created by someone else because why not? Yeah. And you might ask, what is this? Well, I'm also wondering the same thing. It's just a simple table which has 1 million of 1, 2, 3, 4, and it will help us inserting 1 million of data really fast. Like usually it takes like 30, 40 seconds to insert 1 million of data, but we are going to do it in just 2 to 3 seconds. Want to bet? I don't. Okay.
1, 2.
I haven't run it. Okay, but I get it. Okay, now, before that, I had a slide which I casually forgot. Now I'm going to look back because we will need it is this. These are like different steps to create a partition table. If you don't have a table which is partitioned, you cannot do the partition. Sorry, you have to create a table which is from the very start it's been partitioned. And these are the steps for it. And then we are going to do switch in and switch out. So yes, we are going to follow these steps. So for the first step, you can see we have to create a partition function. Do you guys remember what a partition function is? No? Good. I don't too. But we don't need that too much. We need is that this function is something that tells us how the partition is being done. So it takes different values. We talked about right? Right-based partition. This is the right. Okay? If it had left, it would have been left-based. These are like different boundary values. So this is like the start date that I statically assigned it to be the first day of this year. Okay? And then we are just adding 1 day to that start date. So now we have a partition function that has the first day of January as the first partition, the second day of January as the second partition, and so on until the 5th day of January. Does it make sense? All right. You guys are better than me. Took me a whole day. All right. So there we go. We can see there is a partition function that has been created this time, and these are like the fan out. Fan out is something that when we have values, the fan out is always going to be +1. It's a nerdy thing. You guys won't get it. Just leave it. Okay. Now, remember I said that after creating the partition function, we need to create partition file groups. The file groups are like different names, and the files are like the physical files. So we are going to create the file groups, and then we are going to add the files to them. So as you can see, you might ask, can we add more files to a file group? Yes. Can you show me? No. Do it yourself. Okay. So I have created 6 file groups here because there were 6 fan out, remember? Because there are 5 values, remember? Okay. You guys are not goldfish. Good. I'm just nervous. Yeah, other than that, yeah. There's one reason why we are going to create one more. That is actually a very good question. Who asked it? Me. Okay, let's move on. We are always going to have more file groups than the ones we have like values. It's like if we're going to see it in the following examples, but we always need to have one empty space. So whenever we're going to like discard something or add something, we are going to use that one. Especially for this one, we are going to use the one empty one at the very end. Okay? But in practical usage, usually companies assign more than one. So usually there is one empty one at the very beginning, at the end, and another empty one at the very end. So say for any instance, your partitioning didn't work. So the data will be piled up to the one that was not assigned. So since that is not going to happen to us, we are not going to worry about it. So as you can see right now, I told you guys about the primary thing and the log thing, right? So look at this. This is the server. These are the 2 files that I have right now. Can you see? You cannot. I can zoom in. I cannot. So just believe me. The first one is .mdf, which is the primary file. The second one is the LDF, which is the log file. It also says log, in case you don't believe me. So we are going to create these file groups, and you're going to ask me, well, Ree, you just created them, and I don't see anything. Yes, because I just created the names. I haven't assigned any files to them. Okay? But seriously, guys, if you have any question, do ask. I'm feeling lonely. Okay, so what these things are, I have created a dynamic SQL. It runs for 5 times, and it generates this SQL. This is another way of doing SQL. And if you want to do the same thing, and you don't want to do repeated things again and again, you can just write dynamic SQL, and you can just assign different values. Like I'm just increasing I, and I'm just assigning I into there, so that this file name has F1. See, the next one has F2. So I'm creating 6 file names, and I'm also executing it. I'm not going to dig deep into the details here, but if you really want to look into it, you can look into it and then come to me and ask me more questions about it. Okay? So now I'm going to run the same thing here again, and voila. The first one is primary, the second one is transaction. All of the other ones are file groups. I told you, right? Have some faith. These are all .ndf. And you can actually go to the actual server and see that there are, in fact, these things. So I'm not just making it up. Okay, now we have to create the partition scheme. So see, we have finished the first 2 ones. Now the first 3 ones. Now the 4th one. Do you guys remember what a partition scheme was? Anyone? Anyone? Oh, you. Oh, say. So the partition scheme is like, it tells you where different partition boundaries are. Okay? It wasn't that hard. So we are going to create a partition scheme. Before creating it, let me show you if there are any partition schemes. There are not. By the way, if you do it to other databases, you might find. But since I just created this database, there is nothing in this database. Okay? So I created a partition scheme, and we will be able to see the partition scheme here. Am I going too fast? I'm not. Awesome, awesome. Okay, either you guys understand everything or you are very bored with me. Either way, I'll take it. So, final one is like creating a partition table. So all of the things that we did were like prerequisite things just to create a table. So now when we create a table, it knows what are the partitions, where to put any data. And the reason why this might look a little bit complicated is because all of you know about the insert and select queries, right? When we have partition, we don't have to change any kind of queries. So you just say select this from that table. You don't just say which partition. They understand everything. And the reason why they understand is we mapped the thing like that. That's why the earlier stages are a little bit complicated or a little bit tiresome, but it really helps us along the way. Does it make sense? Okay. We are going to create a table. And this is another table that you can create without the partition. Usually this is how it looks like, right? You just create a table with different kinds of column names and their data types. But for partition, what we do, we just say which scheme we want to. And we have multiple column names. You might ask me, okay, Ree, how would it know which column to partition on? Well, because we are providing it with this one, which is the order date. Does it make sense? Okay. So we are not going to create anything without partition. We are going to create this one. And also, the if thing is just, it's checking if that file exists or not. This is another fancy way. I just showed you that I can do the same thing in different ways. Because why the hell not? Can I say hell?
Shoot. Already.
Make it a beep. Okay. All right. Stay with me. So this is like the fun part. Okay? This is now, I'm going to insert 1 million data on each of the partitions. And what I'm doing is, just remember this, I am creating data, and each of them are going to be 1 second apart. So now the question comes, okay, what happens after 86,400? Because that's the amount of seconds we have in a day. So I'm just modding it so that it just rolls up. Does it make sense? Okay. This is not a part of partition. It's just a fancy way of doing it that I did myself. And thank you for the applause that you know what I did. Okay, fine. No, it's okay. I'm just kidding. Okay, now you see that it created 1 million of rows and really fast. And if you don't believe me, trust me, SQL Server believes me. And my mom believes in me, so yeah. So these are like different, if I want to like see a count of it. See, I told you it's going to add 1 second each. Now these are not properly ordered, because another thing about SQL Server is it doesn't insert in order, so you just have to say orderly. It's fine. Oh, what did I do? Oh, it's a different name? Okay, of course it's a different name. Just show you 1 million of data. So especially the people who have worked with millions of data, like Jackson, Rongwa, Neil, and me, we have seen that in order to insert millions of data really takes a lot of time. But you guys ready to count? This is the second batch. Just check. 1, 2, 3. Okay, it's 3 seconds. No claps? Come on. That's not even partition. I don't know why I'm making you guys clap for it. But yeah, it's fun. So yeah. So I'm creating 5 million of data here just to show you guys how it's fast. Usually the tutorials that I found in online were just with 1,000 or like 5,000 of data, but that kind of essentially takes away what partition gives you, the power that it gives you. So I'm using 1 million to show you. And this is something I'm going to do that you guys don't need to worry about. I'm going to create a function that I got from internet. And I mean, I wrote those all by myself. No, it's okay. But I'm going to use it to show you how the file groups are stored. Of course, it doesn't find it. Why would it? Why do I have to lie? It was on a different server. Of course it was. So I have to delete those functions later. Why not? Life is so beautiful. It's okay. It's okay. I have done worse.
What?
Okay, wait, let me see. I'm in partition function. Why doesn't it let me do that? Does it already have these files? I would not hope so. It does. Oh, I haven't created a scheme. Oh, I have not maybe have created a scheme, but I have. Let me check. Already object. Okay, there is an object with scheme like that. We're having some technical difficulties. Stay with us. It was the rain. It was the rain. I swear it was the rain. All right. So I guess it should work now. Yeah! Woo! All right. So now, settle down. You guys are great. By the way. Okay. So here it is. We can see different file groups from 1 to 6. So basically, what SQL Server itself gives us the information in IDs, right? So the things I'm using from other people's code, which are much more talented than me, so they generated ways of like gathering different information and show it in a much more easily, user-friendly way. So instead of showing you numbers, it's showing you the names of it. So it's creating a view, right? And this is the first file group that we can see, which is null because we wanted one to have null. And the other ones are all with different values, right? This is the first day of the year, this is the second, and going to the 5th day of the year. And all of these file groups have 1 million of data. So there are 5 million of data. Does it make sense? Okay. And they are all under this particular scheme. We are going to use this particular view. This is, by the way, a view. We are going to use it again and again just to monitor how our different partitions are working on. Okay, so do you guys have any question? Because we finished the partition table.
If you were to make that same 1 million point insertion into a non-partition regular table, do you know like how long it would take?
It will be it's a very good question.
Yeah.
It will take the same amount of time because hold on there. I'm using one technique of inserting 1 million data really fast. And it doesn't have anything to do with partition. But, so, okay, let me explain you how that is. I'm going to be just touch it, not explain it too much. It's just, it creates a table which contains a lot of data. Wait, where was it? Okay. It just creates a table which has 1 million of data, 1, 2, 3, 4. And then whenever it's trying to insert it, instead of creating different rows, it is actually taking that reference. And somehow it's much more faster because the SQL query execution plan knows things, you know, before doing it. So it makes it really faster. And it can be done in partition, non-partition table as well. But this is something that this guy is from Microsoft, and he created it, and he also designed SQL Server. So he kind of knows how SQL Server works. So you can go to his blog. I have his name and everything here. I don't kind of understand all the technicalities, but definitely you can check it out. Yeah.
Some kind of like compiler optimization.
Yes, definitely. It kind of is like a compiler activation, and a lot of people actually use this function to insert like huge data. So yeah. All right. Coming back to, do you guys have any more questions? If you have, keep it to yourself. So we are running out of time. I'm just kidding. You guys can ask me later. Okay, we have now the switch in and switch out. These are the most important part, guys. This is the most important. We haven't done too much. We have just created a partition table, but we haven't done the most important part, which is like switching and switch out, right? Okay. So for the switch in and switch out, we are going to create a staging table. The staging table is something where we are going to store the whole data, the new data for the new day, right? And then instead of copying all the data from the staging data to the partition table, we are just going to connect it so that that part is like, have you guys ever worked with linked list? Okay, the guys who worked on linked list, it's sort of like it's just connecting the linked list. So it's not physically copying and storing the data. It's actually just connecting the addresses. And this is what it's called metadata operation. So it's not physically moving the data, but it's moving the metadata, which is like the address of these different file groups. All right, and let's see it for ourselves. Okay, I'm going to upload this script as well, so you guys can change, tweak, and if you ever fail, it's okay, just delete the whole database, create it from scratch, and you can just do it. As long as you don't do in a like an actual database. Just create your own database so that you can always delete it, okay? This is my 50th time deleting this database, so figure that out. Okay, so now I'm going to add a new file group, right? And this file group is just the name. So when I create it, when I'm trying to look into the file groups, it does show up. Okay, of course it does show up. But here, it doesn't show up. See? So in our table, this is not a part of it. So what do? We add files to that file group. It's the same way we did previously, so I'm not going to spend too much time on this. And now I'm going to create a staging table. This is important. It might look like the same table we have because it has the same columns, but the most important part is here. We are creating the table on that particular file group. Think about this way. We want to store the data in one particular place so that we can say later that that is the place we want to look for those data, right? So it's not randomly created. It's created on that particular file group. Okay? There are more links if you guys want to go there and see. And now, this whole table is empty, so I am going to insert the data in that table. So to answer Matthew's question again, this is not a partitioned table, but it is actually taking the same amount of time to insert it because the insertion technique is like that. And we have 1 million of data here. I don't want to run it because it will take us a lot of time to query all the 1 million of data. But now, let's move into here. Remember the scheme, the partition scheme? This partition scheme tells us where the individual partitions are, right? So before we do that, let's just look into this. It tells us what the first partition is, what the second is. It tells us when each of these are going to be. So since we added more data at the very latest, like this is going to be the 6th data, so our partition is going to be the 7th number of partition. Do you guys agree? All right. Glad you guys didn't disagree. I wouldn't know what to say at that point. So now I'm telling you it that in this partition scheme, the next used is going to be that file group that we just created. Okay? So we created a partition, a file group. We created files to it. We created a table which is inside that file group, and we stored a lot of data. And we also said to look for data whenever the 6th number partition is going to be finished. But we see, for the 7th one, it is there, but it doesn't know what number of partition it is. It doesn't have any row numbers, because for now, the rows that we inserted were in the staging table, right? So what we do is, we assign the values to the partition function. Remember when I said the partition function detects what are the binary values. So whenever I'm going to run it, I'm just going to say the last value is going to be, the last file group is going to have this value, right? And it will understand that all of the data from there on are going to be on that group. Just run this part and we can just see if that works. Look at this. Now we have, instead of null, we have a 6th partition. And we have this range as well. But we don't have any number of rows. That's kind of interesting. Okay. So in order to move all the data, we are going to, okay, let's just show you guys this. So I made some improvement on the view because I'm good, right? Yeah. I thought you guys would more agree with me, but yeah, why not? Look at this. So all of these have this number of row counts. The last one is our staging table, which is on the sales file group, but it doesn't know that it is a part of that partition table. So now we are going to do the switching part, which is going to take care of this part, okay? And this is pretty easy. We just have to say that table switch to the previous table, the actual partition table, and say this table is going to be part of the 7th partition. How do we know it's a 7th partition? Because I ran this one and I saw that this is the 7th one. If I said partition 1, it would have gone to the first one, but that would just mess up all the ordering. So I'm just going to follow this one. Okay. Now this is interesting. Okay, can I get a countdown? Jacob today told me that if someone counts down, anyone would do anything. Okay, so let's start from 3. 3, 2, 1. Oh no, it broke! Why would it? Why would it not? Because we did not do one thing. If you had been paying attention to me, I had said that there is a lot of things in the partition that we did not do. So, guys, wait. One thing we have to do for partition, that is, we have to make sure the data are contained in that partition. It's never, like, we don't have any wrong data. I mean, we cannot do it, but SQL Server makes sure that we do it. So the previous cases, we did not insert any kind of constraint. If you don't know what constraints are like rules that don't let you do otherwise. So we are going to create 2 rules which are going to say this data is only from this end and that end. Now you might ask me, Ree, you already have inserted data. You should have done it before that, right? I should have, and you should do it. So keep that in mind. In real life, I'm not that bad, trust me. Okay, anyways. So this is the constraint that I'm adding, which is like it's checking if the data is more than that. and I'm adding another constraint, which is checking if the data is less than that. So again, to clarify, we need to do it for each and every one, but since we create it, when we are creating it, SQL Server doesn't give you any kind of error, but once you're trying to do switch in, switch out, you have to do it. See? You have to do it. And I showed you. Otherwise, this will not run. Trust me. Boogeyman is going to get you. Okay, so now that I run it, it stores all the data. You don't laugh. Okay. Okay, now I'm going to run the same thing to see where my data are. And look at this, guys. This is the moment we appreciate. Okay? This is the whole day we have been waiting for. Not even WooBot, not even Code Blue. This is the thing we've been waiting for. Okay? So this is the thing where we can see in the load table there is no data, but in the partition table there is 1 million data. And just think about it. It happened like this. And I did some runtime analysis. It doesn't even take a nanosecond. And you can ask me why. Because it's just changing the address, which is just 1 line. It's not physically removing 1 million of data. It's just moving 1 address line. That's why it's really fast. It's a moment of appreciation. Thank you. Thank you. Thank you. Oh, I'm blushing. Okay. Now, since our work is done with the staging table, we can leave it for later on, or we can delete, drop it. And since I'm not going to use it again, I'm going to drop it. So this was switching in. I'm going to show you switch out, which is a similar way. And after that, we can go and questioning. Since we only have 11 minutes, I'm going to make it a little bit faster. So the way we do switch out is we see what our partitions are. The switch out is going to be the last day's one. So this is the file group FG2, right? So we are going to create a table, and we are going to create the table on file group FG2. Do you guys agree with me? Because we are going to create that and going to kick it out. So we have to say where this table has to be. Does it make sense? Awesome. So yeah, I created the table, and then I'm doing this switching out. Remember when we did the switching in, we just said switch that table to that partition. Now we just do the other way around. We'll just say switch this partition to this table. Okay? And for this, we don't need any constraints because the table itself should take care of that, right? All right. And now we will just run it to see how our data is. Look at this. Okay, this is another moment of appreciation. In the second partition, there is no data, but in the staging table, there is 1 million data. Does it make sense? All right. Now we have these 2 file groups which doesn't have any data. So we'll have to merge them together to be 1 file group, right? So I'm not going to explain this too much. What I'm doing here is programmatically, I'm finding out the lowest merge point. So how we can do it is just by doing the mean, which you guys might have already used a lot, and I'm just doing a lot of fancy things, which just basically does the same thing. So it just checks if there is any data or not. If there's data, it's going to tell me, no, don't do it. And if there is no data, it will say, yes, do it. Okay? But other than that, it's just a simple thing that merges. Okay? So after merging it, I'll see the file groups again from here, and I'll see that the first one only has 0, and the other one's not. And to verify this, look at this file groups. The first one is FG1, but we don't have FG2 because it's merged with the first one. Okay? So we can repeat the whole thing again and again, create more file groups. A good way to do it would be creating a cyclic one, so that after going to 7, it will start from, say, 0. So that we keep on recycling using it and not end up using our millions of, numbers. And since we have a lot of other things as well, we can drop the table. And if we check, we have an extra file group. Remember, we created a file group, but we never deleted that file group. So even though we merged it in our table, the physical file group is still there. So we can just delete the files in the file group, and we can just delete the file group itself. Just one thing to remember, if the file group is not empty, it is not going to let you delete it. So you have to make sure that you have dumped the whole table, then dump the whole files, and then dump the whole file group. Now, another thing, what if we don't want to do this whole staging thing? The only reason why we are doing the staging thing is we don't want to discard the whole data. Usually, when we discard the data, it means we archive the data to another table. Okay? So we always use one live table that the users always use, and for another archive table, we just keep on archiving those. That's why I showed you this way of doing the switch in and switch out. But if you wanted to like truncate, that's even more funny. That's even more interesting as well. Look at this. We have these partitions, right? Say I want to truncate or delete all of the information from one partition. I can just say this. I usually keep my truncate in check so that nobody runs it accidentally. But if I say truncate table with partitions for, or we can use different comma. Say, if I say 3 and 4, just think about it. These are 2 million of data, and they are going to be truncated without even checking. You guys don't realize how fancy this is. It is going to do it like that, without even 1 second. And if we try to see the data, we have get rid of all of those data. Try doing this with delete and where clause. You see it will take a lot of seconds. So yeah, this is how we can do partition. We have 6 minutes if you guys have any questions. If you guys are still alive, breathing well, you guys can do some clapping for me. Oh, you didn't have to. Oh, yes. Okay, one last thing. This is really a complex topic. Even now that I have been working it for like a lot of weeks, it can be a little bit troubling. That's why I wanted to present it. And there are a lot of things that I didn't present it, like different kind of constraints, a lot of indexing and stuff, but those are for like advanced uses. It doesn't mean that you guys cannot comprehend advanced topic. It's just that I will not be able to explain this in this short amount of time. So yeah, any question and comments? I'm also going to upload those to our network library. I'll have to look into where I can upload for like NEURON things. So yeah, you guys can check it out. And a big appreciation goes to these guys, the ones which I took a lot of codes from, a lot of understanding from, especially from Kendra Little. She works in Microsoft and she does a lot of my partition thing. She has her own podcast and everything where she explains things very easily. So yeah, you guys, if you are interested, you guys should definitely check her out.
Which podcast?
You can just search. I did not check it. I saw that she has YouTube channels, a blog post and others. I just looked into the blog post, but they are usually, podcasts and everything listed there. So you guys should definitely check it out there. Any questions? All right. Okay, yeah. Okay, thank you. This time I didn't have to give you the cue. Oh, this is good. Feels earned. Okay. So now I'll just close it up.
One of those.
Really good job.
Thank you.
That's such a good.
Yeah, actually very informative. One phone.